Namaskar. So let's begin in this lecture. Now we have seen about the basic concept of matrix, how to construct what information, how can make the matrix from a given information. Now let's see what type of matrix, in how many types we can classify, and some understanding, because this is very helpful when we proceeding further and try to solve and make much effective calculations based on this. So let's see. So as we have seen about matrix, the general representation, we represent it A, and typically we write it Aij if the order of matrix is m cross n, right? So m represents the number of rows, and then m represents the number of columns, right? And this is your element of the matrix. Okay, so if I need to construct, then how would I write? So I would fill the elements something like this, where my element would be A11, let's say A12, A1j, A1n, right? So here, similarly here you will have A21, second row first column, A22, and so on, A2j, and so on, A2n. Then here you can have, if the order is m cross n, then you will have am1, number of rows m, and then am2, and so on, amj, and so on, amn, right? And then you have so many elements. Now as you have seen that this direction is called your row. This is your first row, this is your second row, right? This is your nth row, and here this is called your column, right? So this is your columns, and this is your row, right? And another aspect you can see here, generally when m is equal to n, that would see that this part is called diagonal, so that would see. So now let's come back and then talk about the different types of matrix. So typically we will see, if you divide the matrix, then we can have typically column matrix, then you would see row matrix, and then you would see square matrix, and we'll see many subclasses in a square matrix, and then we'll have a zero matrix, right? So let's see what they are and what are the subclasses. So when you say column matrix, it means that it have only one column and it can have n rows. So column matrix like for this, right? So this can be your one column, this can be your one column. So for example, you can have a matrix something like, let's say this is A is equal to 0 root 3 minus 1 1 by 2, right? So this is called a column matrix, which is having 4 rows and 1 column, right? So the number of column is 1, then this will be called column matrix. Similarly, if you talk about row matrix, so it will have only rows, right? No, and n number of columns. So for example, you can take the example of this one, right? This one, right? So this one row will completely constitute that one column. So you can have let's say minus 1 upon 2 root 5 3 4. So it would be how many columns? 4, and how many rows? 1. So you'll have 1 cross 4 this row matrix, right? And you can if I talk about representation part, so you can represent in a general form Aij, where you can have m cross 1 matrix, where so you'll have Ai1, right? J will be always 1. Similarly here it would have representation Aij is 1 cross n matrix, right? So this will be the general representation, and typically this will be 1. Now talking about square matrix, what it is? Square matrix. So a square matrix is the matrix when the number of rows and number of columns are same, right? So we'll have let's say it have n number of rows and n number of columns, so you'll have m cross n. Then if m is equal to n, then this is called a square matrix, right? So you can have an example. For example, let's say you have this, then let's say 3 2 4 5 6 4 9 8 7, some fill with the real numbers. Now this can have 3 rows 3 column, and typically you can write that a matrix with the order 3. So you say that order of this matrix is 3. It means that it have n number of rows, 3 number of rows and 3 number of columns, and typically you can represent as Aij m cross m, right, where these two number of rows and number of columns are same, and you can say this is the matrix of the order of m, right. And as I said that in matrix you can get a diagonal, so all the elements in the diagonal, they are called the elements of diagonal. So here in general term, if you talk about, you can have a11, a12, a33, right, a so these are the elements, would be the elements of diagonal, right. Okay, so now we have what is diagonal square matrix. Now coming back, we have some subclasses in square matrix, so that we can divide. So let's say if it is your square matrix, right, so you can have some classes, let's say we'll discuss here. So the one is you can have we can see that the type different diagonal the first thing is that a diagonal matrix, right, what it is, and then it have a subclass which you can further divide it to different types. So one is identity matrix, and the other one is scalar matrix, right. So it's better to understand that what are they and what are the basic differences. So now as we discussed that it have number of rows and number of columns same, right. So you can have when you define diagonal matrix, identity matrix, scalar matrix, they are all a square matrix, and in that identity matrix and scalar matrix all diagonal matrix. So let's say what is your diagonal matrix. So diagonal matrix is a matrix where you have all the elements which is not on the diagonals are 0. So let's say you have a -1, -3 and 4, and all other elements are 0. So this is of matrix where all the elements except the diagonal elements are 0. They are called diagonal matrix, and in a general representation term you can represent, let's say if it is a matrix B and it is represented as Bij for m cross m, obviously because it would be a square matrix where Bij is equal to 0 if I is not equal to j, right. So if I is not equal to j, then all elements, other elements should be 0, and the non-diagonal elements should be non-zero. Now talking about that the scalar matrix. So this is again it's a diagonal matrix. It means that it is a square matrix which is having a diagonal property. So first of all, it would have all the elements 0, right, all the elements 0 except the diagonal. So these elements would be having value, and this can be anything, right. If this is here in diagonal, it can be everything, but here you can have a same value, right, √3, √3, or it can be 2, 4, 4, 4, 4. So if this all elements of the diagonal elements are of the same, then they are called a scalar matrix. So in general term, you can have a scalar matrix represent Cij m cross n, where Cij is equal to 0 if I is not equal to j, and Cij is equal to some constant k if I is equal to j, right. So this is one important point here. Now you have one more condition that these values should be constant and some same value throughout. Now coming back to that other subclass where we can have a identity matrix, which is again a diagonal matrix, means it have a square matrix which have order m. It means it have m number of rows and m number of columns, and here you can say that it is again a kind of scalar matrix which have all the diagonal elements are 1, right, and the rest elements are 0. So of course it is a diagonal matrix because all the elements are 0, and it is a scalar because all diagonal diagonal elements are constant, and again the one unique property is that all elements are 1, so that's why we are having a further subclass that it is a identity matrix, right? So now you understood the difference. The square matrix, all the number of rows and number of columns in the matrix is same. If it is diagonal, it means that all the elements are 0 except that the diagonal elements, which can be any values. If the values are constant, all the elements are same, then it is called scalar matrix, and that scalar matrix where all the elements are 1 in the diagonal, then they are called identity matrix. So these are the different types of matrices. And now you have another matrix you can imagine, that is a zero matrix, right? So we have all the elements are 0, right? So whatever element you talk about, and it can be scalar, not necessarily it is a scalar, it can be rectangular as well. So it can have something like this, you can have something like this. So but the only condition is required that it is a zero matrix, and generally represent it as O. So O can be written as Aij. It can have M cross N, where Aij is equal to 0 for every Ij element of N, right? So this is a condition for zero matrix. So now I hope you understood that the different types of matrix, which is again subclasses of it, and then how you can divide identity matrix, scalar matrix, diagonal matrix. Now you identify your square matrix and your row matrix, column matrix, and zero matrix, right? Now one more important point related to that, talking about that, when we are talking about equality of the matrix. So what is the condition when we can say that the two matrices are equal? So let's see what are the conditions for that. We are talking about equality of matrices. So the first thing that let's say you have a two matrix A, which is represented as Aij of the order of M cross N, right? And the other matrix, let's say it is B, which is Bij of the order of M cross N, right? So these two matrices will be said to be equal if and only if the first condition, they are of the same order, right? So let's say it is M1, N1, it is M2, N2 here. Let's say all the same. So I'm just saying that what is the condition? You have two matrices, so they would be equal, said to be equal if they are of the same order. They are of same order. Same order means what? It means that M1 is equal to M2 and N1 is equal to N2. It means that in both matrices the number of rows and the number of columns should be same, right? That is the first requirement. And the second requirement is that each element of A is equal to each element of B. It means that Aij is equal to Bij, right? Then this two matrices would be called equal matrix. So let's say an example. For example, you have a 2, 3, 0, 1. So the equal matrix to it would be, again, it have all the elements same, and also the order should be same. So it is a 2 cross 2, then it should be also a 2 cross 2 matrix, right? So for example, if you are given that like x, y, z, a, b, c equal to this matrix where -5, 4, 3, 2, 1, root 6, right? So what would it mean? It would mean that first of all you will check that the order of the matrix, so it is 3 cross 2 and it is also 3 cross 2, so first condition is satisfied. The second condition that if they are equal, then each element should be equal. So x is equal to this much, y is equal to this, z is equal to this, a is equal to this, b is equal to this, and c is equal to this. So you can have x is equal to -5, y is equal to 4, z is equal to 3, a is equal to 2, b is equal to 1, and c is equal to root 6. So this is the condition. So if you are given that two matrices are same, then you can find that. So this is very helpful, right? Because now you construct a matrix, at the end you got a linear equations, and then you can just solve that linear equation. You will get n number of equations depending upon the order of the matrix. Okay, so this is all about the matrix, different types of matrix, and also when the two matrices are said to be equal. And now I hope you will understand that what are the different types, where there are differences, where are the order, and if they are equal, then how to treat with that. It means that if the two matrices, if we are going to equate, then they must be of the same order, and each element should be same for the two matrices. Then this is the very important concept related to this. Now we'll move further, and now we'll talk about the operation of matrices, where we'll talk proceeding to towards the algebra of matrix. So see you in next lecture. Thank you.